Hi, welcome to Science Weekly. My name is Ian Lancaster and I will be your host today. Today we'll be going over cellular respiration, which is a process in the mitochondria to produce ATP, both aerobically with oxygen and anaerobically without oxygen. Various forms of cellular respiration include aerobic respiration, lactic acid fermentation, and alcohol fermentation. The main goal of these functions is to produce ATP, adenosine triphosphate, which is used to power most cellular functions. This is done when free energy is released when a phosphate molecule attaches to ADP, adenosine diphosphate, the storage form of ATP.
Today we will be focusing specifically on aerobic respiration, which has 3 steps: glycolysis, the citric acid cycle, and oxidative phosphorylation.
Glycolysis is the first step of aerobic respiration, which is when 2 ATP molecules break down glucose, a 6-carbon sugar, into 2 3-carbon sugars.
The second phase of cellular respiration is the citric acid cycle, which takes place in the mitochondrial matrix. This starts off when 2 pyruvate molecules react to form acetyl coenzyme A, which then acetyl coenzyme A adds to 2-carbonacetyl group to form oxacolate, producing citrate. Citrate is then converted into one of its isomers, isocrate, by removal of a water molecule while simultaneously adding another. Isocrate is then oxidized, reducing NADH or NAD+ to NADH, thus resulting in a compound in the loss of a carbon dioxide molecule. Another carbon dioxide molecule is lost, resulting in a compound oxidizing, reducing NAD+ to NADH again. Acetyl coenzyme A is displaced by a phosphate group, which is transferred to GDP, forming GTP, a molecule similar to ATP that in some cases is actually used to generate ATP. Then 2 hydrogen molecules are transferred to FAD, forming FADH2 and oxidizing succinate. In a few more steps, oxacolate will be formed again, thus keeping the citric acid cycle in a cycle. During this time, only around 2 ATP are formed. Thus, it is substrate level phosphorylation. There. Woo! The third and final step in cellular respiration is oxidative phosphorylation, which takes place in the inner membrane of the mitochondria. During this process, which takes 2 steps, the electron transport chain and chemosis. During the electron transport chain, electrons move across protein complexes, releasing hydrogen ions. What occurs in this is NADH molecules, when electrons pass through, release hydrogen ions, which are then used in chemosis, which is when ATP is actually formed. This happens when ATP, or when the hydrogen ions go back through their membrane, and through ATP synthase, the enzyme that produces ATP thus creates ATP using ions as their power source. And this usually results in around 36. In conclusion, cellular respiration, which is respiration that requires oxygen, has 3 steps: glycolysis, the citric acid cycle, and oxidative phosphorylation. This process usually makes around 36 to 38 ATP molecules per glucose molecule. My name is Ian Lancaster, and thank you for watching Science Weekly. And now for our musical entertainment, Ian, Raquel, and the Animal Cell. Sometimes something beautiful happens in this world.
Oh, Ian, Raquel.
You don't know how to express yourself, so?
And the animal cell.
You just gotta sing.
ATP, and it felt so good.
Felt so good.
ADP, let me put my phosphate inside her. I just need ATP, and I never go back to not making ATP waves of the past.
Have you ever
Guess where I just came from? I made ATP. If I had to describe the feeling, it was the best when I made the ATP. Man, my cell had energy, and I called G Red Rocket. I was done.
Oh hey, didn't see you there. Guess what I just did? Made ADP, UGLS Arm Transportation, and the rest.
Well, sure, nice of him to do that thing.
Fastest organelle ever.
Now sing.
I just made ATP and it felt so good.
Felt so good.
ADP let me put my faucet in fiber. I wanna tell you.
To be honest, I'm surprised the cell even let me oxidate or phosphorylate.
Doesn't really make sense.
But man, screw it.
I ain't one to argue with the good thing.
She could be my wife.
That good?
The best millisecond of my life.
My life.
I'm so humbled by cell's ability and respiration.
Because honestly, I'd make the ADP by photosynthesis. With that in mind, soft, nice smell and respiration better.
My cons let me wear my pain and my turtleneck sweater. I was jumping up and down,
I got beaten up by Jordan.
and I cried the whole time.
Someone put a bang on my head.
I just made ATP, and it felt so good.
And it made me let me put my phosphate in fiber.
I just made ATP, and I'll never go back.
We're not making ATP